Okay, enough on the theory of rocket science. Let's take a look at what happens to people when they go into space. That's the main reason most of us are in the aerospace business, and it's an area of special importance to aerospace technicians who work on the systems to keep people alive once they leave the Earth. As you can see on this chart, there are a lot of things that happen to the human body once we leave the Earth's atmosphere and the influence of its gravitational field. Even though the spacecraft is still captured by gravity, or we'd be going to the Moon or Mars, not just working on a space station in near-Earth orbit, we experience what is called microgravity, because we sense the free fall as little or no gravity acting on our bodies. You can get the same sensation briefly on a roller coaster or an airplane when you drop down for a few seconds and have nothing to push against, as you have all your life on the Earth. People who fly into space experience a whole spectrum of new forces and feelings when they go into orbit. As they're free-falling through space, they experience weightlessness and their bodies react in strange new ways. Everyone has some degree of adaptation, and some do better than others, but it's difficult to predict how even experienced test pilots and others will react once they reach weightlessness. Many become ill for at least a short time. For example, your body fluid on Earth is pulled down into your legs and feet as you stand on Earth. It's quite natural and something we don't even think about. It just happens. But when you go into orbit, your body senses a change as the fluid in your legs is no longer confined by gravity, and it shifts around to equalize pressure and redistributes itself. You might feel bloated. Your face gets puffy, and your body reacts because now there's more fluid than you need, and you'll need to use the bathroom to get rid of the excess fluid caused by this shift. For similar reasons, all the muscles required to keep you upright and breathing in the Earth's gravity no longer are being tasked to do anything. Unless you decide to exercise those muscles, they begin to shrink in size and strength, and it happens pretty quickly. That's why astronauts exercise daily, sometimes for 3 to 4 hours, to preserve muscle mass and strength. They work out not only to continue to function while on orbit, but also to ease the pain of returning to Earth and having to reverse all those reactions when they acclimate back to 1G activities. Bone loss is a problem that can become significant for long-duration flights. Bone loss occurs for similar reasons as muscle atrophy, but recovery takes much longer, and the long-term implications can be very serious. Efforts continue in medical research aimed at understanding and minimizing long-term bone loss for lunar and Mars missions. Crews on spacecraft are called upon to perform a variety of tasks in a tremendous span of environments, from the air they breathe to the food they eat, the way they sleep, how they maintain cleanliness, and what they do to stay fit during long missions. Physicians and flight surgeons continue to develop a number of what they call interventions to minimize or prevent problems to the extent possible. Although no one likes being a test specimen and everyone wants to feel good all the time, actions are required to respond to the body's reactions to living and working in space. An example is the requirement to drink fluids to hydrate your body before re-entry and return to Earth. If the flight crew is not properly conditioned, they run the risk of passing out during crucial maneuvers when the force of gravity returns during flight operations, and especially when they step off the spacecraft upon return to Earth, when gravity again causes body fluids to flow back down into the legs and feet, sometimes causing crew members to faint because too little fluid remains to supply the brain located at the top of our heads. Experiments continue on these and other biomedical issues, and good technicians will need to learn more about the risks to flight crew and how to assure systems and equipment function as needed to eliminate issues caused by poor maintenance, shoddy workmanship, or just plain ignorance contributing to problems in systems that are critical to crew health. One of the toughest problems facing future space missions is the threat posed by radiation to crews who fly above the Earth's atmosphere. Cosmic rays exist in large amounts and are continuously bombarding the Earth, but the blanket of air above us keeps most of them from reaching us on the surface. Flights outside the atmosphere, especially long-duration flights, such as those to Mars, expose the crew to possible danger from increased radiation due to sunspots and other sources that cannot be predicted. They're difficult to shield because of the demands of energy and spacecraft design that require the use of heavy metal shielding or similar structural approaches to protect inhabitants of a flight vehicle during long-duration flights outside any planet's atmosphere. These are the kinds of issues facing scientists, engineers, and career technicians who will be working on the spacecraft systems of the future. The actions listed at the bottom of this chart provide examples of current actions taken to maintain crew effectiveness upon return to Earth. No one knows what will be needed when we establish a permanent lunar base, but it's a good bet that years away from 1G of Earth will require new interventions in ways we have no idea about today.